Welcome, this is Arnold, Assistant Professor, Department of AI&DS, working in KIT, Kalangir Karnataka Institute of Technology. Today I am going to take the subject Design and Analysis of Algorithm. Topic is Advantages and Disadvantages of Divide and Conquer, Decrease and Conquer approach using Topological sort. So, advantages of Divide and Conquer. First one is parallel work. After we split a problem into smaller ones, those problems can often be solved at the same time. This is very useful for computer with multiple processors. First advantages. Second is better use of memory. So once a small problem is fit into the computer's faster memory, cache memory, it can be solved quickly without needing to fetch the data repeatedly. Third point, it makes the harder problem very easier. So we take any tower of honey problem, it makes very easier. We can solve the problem very easy because we are going to program into the smaller parts here. Fourth point, helps discover for other fast algorithms. The many well-known fast algorithms like quicksort and mergesort can be created using this method. So disadvantages of divide and conquer method. The recursion can be slow here first. The repeated function calls in the recursions can make the program slower in some cases. First disadvantages. Second disadvantage, sometimes too complex for small problems. Adding a list a number, a small loop is very easier and faster than dividing the solving recursively. Next one is repeating the same work. Sometimes a smaller problem is solved multiple times. We are going to waste time, so this can be avoided by sorting the results for users memorization. So next concept, decrease and conquer techniques. It is a problem solving method where we solve a problem by making smaller step by step until here we are going to reduce the problem. There we are going to divide the problem here. We are going to reduce the problem here. Then make the problem smaller again and again until it's so small you can solve it easy. So difference between the divide and conquer method and decrease and conquer method. The divide and conquer method, you break a small problem into several smaller problems, solve each and combine. In decrease and conquer, you just make the problem a bit smaller each time and solve until done. Implementation of divide and conquer method. So top-down approach starts with a big problem, reduces, solve the smaller problems and so on. Bottom approach starts from smallest versions and build up to big one. Variation of decrease and conquer, nothing but there are the three variations of decrease. One is decrease by a constant, second decrease by a constant, and variable size decrease. Decrease by constants, each step reduce the problem by same fixed number. Example for this constant is insertion sort, DFS and BFS. Topological sort example. This comes under the topological sort. So topological sort. In the topological sort of a diacyclic graph, G is equal to V comma E, vertices comma edges is a linear ordering of all vertices such that if a graph contains the edges U comma V, then U appears before V in ordering. Okay. If the graph forms a cycle, then is no linear ordering is possible. The topological sort of a graph can be viewed as an ordering of its vertices along the horizontal line, so all its directed edges from left to right. There are the two methods used can solve the topological sort. First method is DFS method, second one is source removal method. We are going to discuss first method, DFS method. So here we can choose any node here, vertex. When the vertex is visited for the first time, push into the stack. We are choosing the vertex, we are going to push the stack. When a vertex becomes a dead end, there is no possible moves, means it is removed from the stack. We are going to remove the corresponding vertex from the stack. The same process repeated to second and third process for all the vertices in the graph. Reverse the order of deleted items to get the topological sequences. Consider the example. This is the graph. Initially, the stack, first A is the vertex, choosing any vertex. So adjacent of A is nothing but first I am going to visit the node A. Okay, so stack is no pop. Second adjacent to B is A is nothing but B. So we are going to node visit A comma B. Stack is pop. Again adjacent of B is nothing but E. Okay, we are going to node visited E. Again next adjacent to E, there is any adjacent to E? No, there is a dead end. There is no incoming edge for the E. So we are going to remove the E from the stack. Okay, so we are going to remove the means we are going to pop the E value here. So E comma A comma B only. Again we are adjacent to the B, we are moving to G here. So after the G there is adjacent of F, then there is no adjacent means we are going to remove the stack. So popped order is nothing but E, F, G, B, C, A, D. Topological sort is D, A, C, B, G, F, E. This is the topological sorting. So this method, this algorithm is based on the direct implementation of degrees and conquer techniques. So second method is we are going to use the source based method. The order in which the vertices are deleted aids the solutions to the topological sort problem. So this is a second method, source vertices method. Identify the remaining digraph in a source where the what is concept here means which the vertex with no incoming edges. The vertex with no incoming edges, we are going to delete the corresponding edge here. So first one is the source removal algorithm for topological problem. So here there is no edge for C1, incoming edge for C1, so we are going to delete the C1. Again there is no edge for C2, we are going to delete for C2. Again there is no edge for C3, so we are going to delete the C3. Again we are going to delete the C4 and C5. So the solutions obtained C1, C2, C3 and C4 and C5 only. This is the final answer. So algorithm nothing but at each step pick a vertex with no incoming edges, add it to the output list, remove it. Okay, remove from his graph, repeat until all these are removed. So time complexity of the topological sort is big O of V plus E, vertices plus edges. Application of topological sort is mainly instruction scheduling in program compilations, cell evaluation ordering in spreadsheet formulas, resolving the simple dependency in linkers. Thank you.